In this video, I will talk about molecular geometry and the VSEPR model. So what is this model and what is the definition of VSEPR model? So this model is used to predict what? To predict the geometry of individual molecules. To predict the geometry of individual molecules from the number of electron pairs surrounding their central atoms. From the number of electron pairs. Alright? So, there's another thing that I should know before I get started to some molecular geometry examples. What is an electron domain? So, electron domain. What is electron domain? Electron domain is the number of bonds plus the number of lone pairs. Alright? First, let's have example of a molecular geometry. Let's see CH4, methane. So methane, you know the methane, how its shape. We write C in the central, then H, H, H. You know that carbon can attach with 4 hydrogens, or it can make 4 covalent bonds, single covalent bonds. Alright, so this is methane, CH4. So what does VSEPR model tell us here? This shape has an angle of 109.5. So what is the shape of this methane? Let's just draw this CH4 in a 3D shape. So it will be like this. Let's change the color, please. C H H H and H. So how could we do the geometry model for this? It will be something like this. So this is the shape of tetrahedral. This is its faces. So this is the shape of tetrahedral. Tetrahedral. And now let's go deeper into some other shapes that our VSEPR model describe it. Now let's just have an example of trigonal bipyramidal structure. Trigonal bipyramidal. Alright, so let's just have an atom. Let's just call it by A, and this atom is surrounded by 4 atoms which is attached by, so let's just say X, 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 and the 2 rest atoms are like this, X. So what we need to worry about here is the angle bound here between these 3 atoms and the angle here. So what would be the angles here? We know that the angle between these 3 atoms are 90 degrees. But what about these? If you look at this, these three atoms, they shape like a triangle planar shape, which is if we have an atom like this, A, X, X, X. This shape has a triangle planar shape. So the angle between these 3 atoms, or the bond angle, is 120. So the angle here should be also 120. Alright? A good example for this shape is phosphorus pentachloride, PCl5. So let's just draw the central atom, which is phosphorus, then chlor atoms here, here, and here. So we know that phosphorus can attach by 5 valence electrons. So, and chloride can attach by 1 valence electron. So now what it will have, 3 electron pairs here, and also here the same, the rest of atoms. Alright, so now this shape is completely perfect, and the angle between these 3 atoms are 90 degrees, and here is also 120, and it's of course trigonal bipyramidal structure. Alright, let's have another example. Now we came to the most interesting thing. As I said before, CH4, which is methane, is a tetrahedral shape, and the angle bond here is 109.5. Alright, so here we have 0 lone pairs. 0 lone pairs. But what if we have 1 lone pair? Let's have an example. An example of 1 lone pair is NH3. So let's just draw it. NH3. and 3 hydrogens. We know that nitrogen has 5 valence electrons, so if we associate with 3, it will lift 1 lone pair. Alright, so 1 lone pair will reduce the angle by 2.5 degrees. So 109.5 minus 2.5, which will be approximately 107 degrees. Alright, so what if we have 2 lone pairs? Sounds getting interesting, right? So let's just have water. Water is H2O. O is central. So let's just have the same color, purple. So water is, oxygen is the central atom here, and we have H, H. And of course, because oxygen have 6 valence electrons, so if he attached with 2 of them, so it will left 2 lone pairs. And as I said before, it will reduce, 1 lone pair will reduce about 2.5 degrees. So let's just have 109.5 degrees minus 2 times 2.5, and it will be 104.5 degrees. So the angle bond here is 104.5 degrees, right? So another important shape is seesaw shape. Seesaw shape or structure. So do you know what is a seesaw? A seesaw is like this. Let me just show you this picture. So this is a seesaw. If you can see here, it's a game. So this game shape has its base and its upper structure and its down structure. So how it would be look like if we make it like a structure. So if we have an atom that we call by, let's just call it by A, and it has it is attached with 4 atoms, so just call it by X here and X. And the base of the seesaw should be like this. This is the base, X and X. And also it has 1 lone pair. So that's it. This is a seesaw structure. We have an example, a good example of seesaw structure as CF4. CF4. So let's just draw its shape. SF4. So sulfide is the central atom. It will be like this, and we have 4 of fluoride atoms. So it will be here F the left side, and the base of seesaw. As we know that sulfur has 6 valence bonds. So what it will left with him is one lone pair, which is contain of 2 electrons, of course. So it will be one lone pair. And just complete the structure. 3 lone pairs for every fluorite. And the last fluorine. So that is the seesaw structure.